So last day, we
recorded.
have been completed the discussion about exceptions and exception handling, right? Yeah, we just been looked into the concept of exceptions. How do we use exceptions in your code? Okay, and also exception handling. Yeah, the next topic, what we are just going to discuss today is about delegates. Okay, so delegates. Delegates is the next topic what we're just going to talk. So what are these delegates? Actually, a delegate, talking about a delegate, what the delegate means? Delegate. This is also a type like class, structure, interface, enum. So actually, what did I say? Array, C# supports you. C language supports three types. What are the three types? Structures, enums, unions. Structures, enums, and unions. These are user-defined types basically. Okay, you can define your own structure, you can define your own enum, you can define your own union, but C# supports your five types. What are the five? Class. We know this, and I said your 90% of the things what you come across in your code is classes. Second one, structures. Mostly we don't define them, but we consume them because all the predefined data types, which comes under value type category are structures only. Int is a predefined structure. Float is a predefined structure. Char is a predefined structure. Bool is a predefined structure. They're all going to be structures. Third one is interfaces. Fourth one is enums. And the fifth type is delegate. So what's a delegate? This is also a type like a class or a structure or interface or a enum. Next, see, look. Actually, before I explain about the structures, I want to raise a question here. What are they? Most of you, when you learned your C language, you might be coming across a concept called as variable pointers. Variable pointers. What's a variable pointer? This holds the address of a variable. This holds the address of a variable. For example, I'm declaring int I is equals to 100. So I is a variable which is going to store a value 100. But for this I, some memory is allocated for you internally now. So I see in the memory internally on your ROM, the memory is going to be allocated for I now. The memory is going to be allocated for I. You are living somewhere. See, you are living somewhere. You have an address. Same way, every variable also has a address. The address where exactly this is stored. Okay. And if at all you want to get the address of that, how do you get the address? You know, ampersand I. I refers to 100. Ampersand I refers to address. It refers to the address actually. Okay. And to store this address, we are provided with a concept called as pointer variables. How do you declare this pointer variable? A normal variable only. We prefix with a asterisk operator. So this is called as a pointer variable. So what is a pointer variable? Or variable pointer or pointer variable, both are same only. How do you declare it? By prefixing a star. So when you prefix the asterisk here, it's a pointer variable, and this is how you refer to the address of it, ampersand I. Okay. Now see, listen. We can now access a value 100 in our code in two different ways. In two different ways. You can access that value 100 in two different ways. How you can access? First one, you can access it. We can access it through the variable I. We can access it through the variable I. There's one way how you can access it. Second, we can access it through the pointer. Two ways you can just access it here. One is using I you can access. Two is using P also we can access. But which one is faster? As accessing through the variable or accessing through the pointer? Louder. If variable is faster, what do they need a pointer then? Pointer is faster here. Pointers are faster because a pointer provides you a direct access to a memory now. Are you clear? I say a person is living in this area. I say a person is living in this particular area. To catch that person, it takes some time now. But I say the person is living in so-and-so house and so-and-so street in this area. You directly go there and meet him now. So this is also same. When I say ampersand P, I'm directly telling you the address now. When I refer to the address, you can directly find the person easily. So it's also accessing it through the pointer is faster. Why, sir? Because it provides you a direct access to memory. Okay. So what is that? Accessing the value through the pointer is faster because it provides a direct access to the memory. It provides a direct access to the memory. Okay, now? Fine. Same like this here. Same like this. We have another concept also in C language. What is that, you know? Function pointers. This holds the address, or exactly speaking, we call reference here of a function. Here also address. Same, variable pointer will hold the reference of a variable. Function pointer will hold the reference of a function. It will hold you the reference of a function. And guys, in telling you, I'm talking about C language. I'm not talking anything about the C# language. Put that in the mind first. Are you clear? Oh, sorry. Starting from here, what I'm explaining is about C language. It's all about C language. Okay. See guys, now, for example, you have defined a function like this in C. You have defined a function like this in C. Public void add int x comma int y. Inside you're writing int z is equals to x plus y. Printf percentile d, or otherwise value of z is, or otherwise sum of given two numbers is, we put a percentile here, comma z. That's what you learned already in the C language now. So what happens? The z will be substituted at this particular place, and finally you will see the result. Okay, this is a function. Now you can declare a function pointer, just like we declared a variable pointer on the top. We can declare a function pointer now. We can declare a function pointer. How to declare function pointer? Something like this. Public, okay, like void. Here we don't require like public or something. Public star FP. Some name. I'm giving the name as FP. FP in the sense function pointer. And afterwards, int comma int. Understand? What is this void? Void implies the function is non-value returning. Here also void only, see? They will match now. Now, this is the name of function pointer. What is the name? FP. What is this? This indicates this takes two integers as a parameter. See, you're passing here. Yes or not? The same two integers should be present here. See here, if the written type is a float, here also it will be float now. Suppose it takes one integer, one string now. Here also it will be intent string. So they are going to match with each other. This is how you declare a function pointer. Is equals to what? Ampersand and. You've done the same thing only, see? Star P is equals to ampersand type. But this is a different style of FP. Name is same. But here we have return type also, parameter types also. Is equals to ampersand. What happens now? The address will come and store under the FP now. The address will come and store under the FP. Okay? Now listen. We can now not access it. Call the function. Call the function add in our code in two different ways. We can call the function add in our code in two different ways. What are the two different ways? Option 1. We can call it directly by using its name. That is, this is how you can call add of 100, 50. You can call it like this. Understood? Second, we can call it by using the function pointer also. That is, you can call it like this here. That's how you can call. Both will execute the function. The first one is also function call only. Second one is also function call only. Got it? Which one is faster? Pointer caller, function caller, direct caller. Pointer call or direct call? Which one is faster? What are you thinking? Louder. Pointer call. What is faster? Pointer call. Why? Because it louder. I did not understand. Function pointer, direct access to memory. It provides you direct access to the memory. You use the same medicine for all diseases. Tell me, for every disease you'll use the same medicine. Then I said something for variable. Why are you linking that with your function? Both are different concepts here. Variable is a value. Function is a value. Then if you directly access, what is the advantage? Understand, man, what is a function? A function is a block of code, not a value. If you directly access, the code won't execute faster. That is not the reason. That is the reason what I said for variable. Because variable pointer means basically it's a value. It's just a value. But here it is not a value. Here it is a logic. The logic to execute. A direct access to memory doesn't execute the logic faster. No. Okay, understand. That's not the reason. Calling it through the function pointer is faster, but not because a direct access to memory. Why is it? Listen. Generally, a function is a block of code. A function is a block of code. Tomorrow, you're writing a function with some 100 lines of code. Now, what the function has to do? The function has to execute, and finally, we should give you the results back now. Should give you the results back. For example, it has to process some logic. And after processing the logic, the final result should be given back. And to process the logic, you need some memory. To process the logic, you need some memory. So what happens, whenever a function starts execution, operating system will create a stack and gives to the function for storing its values now. What happens? Operating system gives a stack for the function to store its values. And now the function executes all the logic in the stack now. And finally, it will return the results back and the stack is destroyed. Like that, you enter into a grocery store. They're giving you a basket. What are you doing? You're filling all the items into the basket and going to the billing counter, get it billed and leave the basket and get your products now. So the basket is with you until the time you're in the store only. You enter the store, they'll give you the basket. When you're exiting the store, you're required to leave the basket there. Are you clearer or not? So here also, it is the same thing. What is it? When the function starts the execution, operating system provides a stack now and tells execute all your logic and finally return the basket back. Return the stack back. Okay, the stack is created when the function execution starts, and in the end of the execution, the stack is destroyed. Did you understand this first? Suppose if I call a function for 10 times, if I call a function for 10 times, 10 times the stack is created and destroyed. I call the function for 10 times and 10 times the stack is created and destroyed. Every time it will be creating a stack for you and destroying the stack for you. Creation, destroying, happens all the 10 times, which could be a time-taking process. Which could be a time-taking process. It's a time-taking process. Okay. So whenever you try to do this, every time creation, destroying is going to be a time-taking process. So you can avoid it basically with the help of function pointers. How you know? When you declare a function pointer, for a function, there will be a dedicated stack. There will be a dedicated stack for the function to process the logic. I repeat, there will be a dedicated stack for the function to process the logic. You call it for 1 time or you call it for 10 times. It uses the same stack actually. It uses the same stack. That is why calling a function through a function pointer is faster. But here conditions apply. What conditions apply? You want to call a function only for 1 time. Don't use a function pointer. Why? Again, declaring a pointer, calling it through all the waste of time. When should I use it? I want to consume this function for multiple times in the code. I want a function to execute for multiple times in a code. If you want to execute a function for multiple times in the code, that is the right time where you just require to go for using a function pointer. For 1 time calling, using a function pointer is waste. For multi times calling, then only go for using a function pointer. Is it clear, all of you? So what is the advantages at you? There will be a dedicated stack for the code to execute. So it's not direct access to memory, guys. Remember. Okay, what is it? Calling a function through function pointer is faster and efficient than calling a function directly. Calling a function through function pointer is faster and efficient than calling a function directly. Provided, what is that I said to you? Provided we need the function to execute for multiple times. 1 time calling using a function pointer is a waste. Understood my point or not? 1 time calling using a function pointer is waste. Understood me? See, once in a while, every month, once you go out for an outing. Every month, once you go out for an outing. Because you're going every month once for outing, purchasing a car is waste of money. Did you get my point or not? Once in a month you go, means for a year you travel 12 times. For this, what you thought is, why don't we purchase a car? You invested from 15 to 20 lakhs and purchased a car. Waste of money. The best thing is, hire a car now, enough. No need to purchase a car. Here also, 1 time I want to call a function. Waste of a function pointer. When you should use a function pointer? When you're going to use it for multiple times. Exactly. See, I travel every day. Here and there. And in this process, the climate is very hot, the climate is cold, or the climate is rainy. Yeah, I got a car. That's a good process. That's a good thing. Fine. But once in a blue moon you travel and you purchase a car is a complete waste of money. Got it or not? So here also put the same thing in the mind. What is it? Once I want to call a function, directly call off, no problem. I want to call this function for multiple times, then go for using a function point. Okay. Now coming back, why did I explain about all these particular things here is, do we have variable pointers in C Sharp? Do we have variable pointers in C Sharp? What is your answer? Yes or no? What is the question? Do we have variable pointers in C Sharp? Yes, we have variable pointers in C Sharp also, but we can use them only as method parameters. We can use them only as method parameters, and the declaration is done by using, all of you know this here, you learned it already, by using ref keyword. How do you declare? By using the ref keyword. You remember this, guys? Public void math int a comma int b comma ref int c comma ref int d. We already learned about this. What is a and b? Input parameter. What is c and d? In-out parameter. The in-out parameter is internally a ref parameter. It is going to be a reference parameter. Input parameter and this is a in-out parameter. Nothing but a reference parameter. So this is a pointer variable, guys. So understand carefully. We have variable pointers in C Sharp also, but we can use them only as, you cannot use wherever you want. Where you can use it only, method parameters only we can use them. And the declaration is done by using the ref keyword. Okay. Now inside of it, what do you write? C is equals to A plus B. D is equals to A into B. Okay. Now listen. How do you call this? Tomorrow, you go to main method. So this is your main method. And in the main method, imagine you created the instance of the class under which the method is present. The name of the instance is obj. The name of the instance is obj. And you want to call the math. How do you call? Int sum is equals to 0, comma, product is equals to 0. First you're declaring two variables. The normal variables, what do they hold? Sum holds 0, product holds 0. Now you're calling the function. How you call? Obj dot math. You're passing 100, comma 25. You're passing 100, comma 25. So what will happen? The value 100 will go to A now. The value 25 will go to D now. And the C and D are input parameters or in-out parameters? In-out parameters. What we do, we say comma ref sum, comma ref product. When you write like this, what happens, what is this, this is equivalent to ampersand sum. This is equivalent to ampersand sum. Means what you're referring? Address. What you're referring to? Address. Now the address of the sum will go into C. Why, sir? Because that is a pointer variable. Doesn't hold a value. What it holds? Address. What am I passing? Address. When I say ref sum, the address will come to C now. When I say ref product, the address will come to D now. So C and D are holding what? Address. Now you said C is equals to A plus B. Means 100 plus 25, 125 is assigned to C. But C cannot hold a value. What C can hold? So whatever you assign to C is redirected to sum now. I'm talking with you only, man. Whatever you assign to C is redirected to sum now. Means once this logic starts executing, C is equals to A plus B. What is A? 100. What is B? 25. What is C now? 125. Assigned to C, but C cannot hold a value. C can hold only address. So what you assign to C will now be reassigned to sum now. Now sum contains 125. Okay, again the same thing. D is equals to A into B. How much? 2500 is assigned to D now. So whatever you assign to D is redirected to product now. That's why once the execution is completed, this contains the sum of the two numbers. This contains the product of the two numbers. And these two are pointer variables. And this is a address operator. This is nothing but ampersand sum, ampersand product. Is it clear? Just I written the same thing here, but variable names are a bit different. Just a second. Just a second, loading. Yeah, watch it. AB, ref into C, ref into D. Okay. Now here you declared four variables. M is equals to 100, N is equals to 25, P is equals to 0, Q is equals to 0. Now you called. What are you passing? M. Array, in the code directly passed 100, but I'm passing variable. Now the value of M goes to A now. See, first all on this line, all the variables are declared. On this line, all the variables are declared. What is M? 100. What is N? 25. What is P? 0. What is Q? 0. Now you call the function. Now you said math of M. So what will happen? The value 100 goes to A now. N. The value 25 goes to B now. Now what you said here? Ref P or P? Louder. When you say ref P, the not the value, the address of the P is going to C now. See, watch it. When you say ref Q, the address of the Q is going to D now. See, first you started here with this, and now these two values and these two addresses went to the things. Are you clear? Now the function starts its execution. 125 is assigned to C. The C will see the double arrow mark. C say in out. First you pass a address, then it will pass a value. You are passing an address. What is it passing you back? Value. The value 125 will come to P now. Afterwards, the value 2500 comes to Q now. In the end of the execution, this is how it will be. After destroy. Destroy, it will destroy. It won't be long living, na? It will destroy. But understand, you got back your results. You got back your results. Once you got back the results, the function stays in the memory or destroys in the memory. What for me now? I got my results. The final result is here. So look, this is the starting of the execution. This is the starting of your execution. Clear? And this is the ending of your execution. Once the execution is completed, this is the ending of your execution. Okay, now tell me, okay, that is what? Starting and ending. These are the two things what we just have. Starting of the execution and ending of the execution. Starts like this, ends like this. So finally, what is that? Do we have variable pointers in C#? Yes. We have variable pointers in C# also. How do we declare them? We declare them by using ref keyword. We declare them by using the ref keyword. The ref keyword is used for declaring the variable pointers. Same like this, do we have function pointers on C#? The next question is, do we have function pointers in C#? The answer is yes. And we call them as delegates. To tell you this, I said you all these particular things. What's a delegate? A delegate is a function pointer. A delegate is a function pointer which stores the address or reference of a method in it to call it. Okay? So listen. A delegate is a method pointer. For us, no function. What do we say? Method pointer, which will internally store the reference of a method in it and can be used for calling the method. Can be used for calling the method. Okay? And remember, calling a method by using a delegate is faster and efficient, provided we want to execute the method for. Once again, I'm telling you. Um, Once again, I'm telling you this. What is that? You want to use it for one time, no need of using these delegates, the waste of time. You want to use it for multiple times, then it is important. Suppose, say, tomorrow you're creating a GUI application. There is a button. On the click of a button, what is happening, on the click of your particular button, internally, it is executing a function. Imagine, on the click of a button, it is executing a method. Now, the user can click on this button only for one time or multiple times. Multiple times. Imagine the user clicked on the button 10 times. The method will execute 10 times now. Yes or not? In such type of scenarios, never perform a direct calling. Always use a delegate call. Always use a delegate call to the method. So the user clicks on the button for 10 times or 100 times. Behind the screen, what happens? A delegate will be used for you internally. Are you getting my point? What is used? A delegate is used for you internally. That's what exactly happens to you behind the screen. So this is the process. This is how you are going to, this is how you are going to use it. Okay, but let me tell you how to use a delegate and call a method. How to use a delegate and call a method. Am I clear till now? So now the question will be how to use a delegate and call a method. How to use a delegate and call a method. Okay, how to use a delegate and call a method. Okay, so listen, how to use a delegate and call a method. So this is the big question what we'll have in the minds. How this delegate is going to be used and the methods are called. Okay, listen. To call a method by using delegate, adopt the below process. I repeat, to call a method by using delegate, adopt the below process. What is it? Step 1. Declare a delegate. Step 2. Instantiate the delegate. Step 3. Call the delegate. To execute the method. So watch it carefully. What is the first step? Declare a delegate. Second step, instantiate the delegate. Third step, call the delegate to execute the method. These are the 3 steps. So the first step, let's try to understand how to declare a delegate. How to declare a delegate. Syntax to declare a delegate. Modifiers, delegate, void or type, name, parameter list. Parameter list. Okay. And a very important note to remember. What you know? While declaring a delegate to call a method, make sure parameter types of the delegate and return type of the delegate exactly matches to the parameter and return types of the delegate. Did you understand? Already in the variable, in the function pointer on the top also I said you that one. Function is void, delegate is also void. Function is taking two integers. Delegate is also taking function point is also taking two integers there. Same point I'm telling you. If the function is, if our method is value returning, delegate also should be value returning. If the method is non-value returning, delegate also should be non-value returning. If the method takes n parameters, delegate also should take the same parameters. Same type of parameters. You can't change this. There are three integers. Here can I take three floats? No. Three integers only here also. Did you understand the note or not? Okay. Well, imagine this is a function. This is a function. Console dot right line a plus b. This is a function. Non-value returning function. This is another function. Another method. Okay. Public string, say hello. String name. Return hello plus name. Right. Simple code here. Okay. And guys, I want to define this as a static. Right. One non-static, one static. One is non-value returning, one is value returning. Now look at this syntax here. And look at this function here. And look at the note here. I want to declare a delegate now. Can you help me? Come on. Public delegate void. Give a name to your delegate now. Any name you like. Any name you like. I'm giving the name as add delegate. Okay now? What next? Parameter list. Int A, int B. In C language here, int comma int. But here we explicitly use the names. Int A, int B. Any name here you like. Doesn't mean that the names has to match. Both are int or int. That's what it matches. A, B, that's none of the business. Are you clear? In C language, it is quite simple. You don't require to write this. What do you say? Int comma int. But here we should explicitly list out the names here. Okay now? Come on, help me. I want to define a delegate here. Public delegate string, say delegate string str. Method is static. Even method is static also, no matter. We don't require to use static on the delegate. We don't require to use static on the delegate. Okay. Well, a small thing I want to say you. Just a minute. Calling method by using methods by using delegate is faster and efficient, provided we want to execute the method for multiple times. Okay. Up to here, you are clear now? Just a minute. What do you know? A delegate can be used for calling both static and non-static methods also. You can use a delegate for calling both static and non-static methods also. It's not like we can use it only for static or only for non-static. You can use it for both. Are you guys clearer or not? Okay, you can use it for both. Static also we can use, non-static also we can use. Okay, another important thing. In C#, we can call methods in two ways. Those are option 1. By using name of the class or by prefixing name of the class if the method is static, and by prefixing instance of the class if the method is non-static. You know this here. We already completed this one. I am not telling you only. We already learned it now. Till now, how are we calling the methods? Either by prefixing the name of the class or either by prefixing the instance of the class, provided it is static and non-static. That discussion is over. We are learning the new thing now. What is that? By using a delegate. By using a delegate. And here I should say both static and non-static also. I don't require to mention again this one. Now it will be quite simple. You understand that. In C#, we can call methods in two ways. First one, by prefixing name of the class if the method is static, and by prefixing instance of the class if the method is non-static. And this is a old story. We are already doing it from the last 1 month. We are doing it from the last 1 month. Second option, by using a delegate, both static and non-static. Static also we can call, non-static also we can call with the help of a delegate. With the help of a delegate. That's the process of calling the things. Okay. So are you guys clear about how to declare a delegate? Step 1 is completed when? What is it? What is step 2? Instantiate a delegate. What is instantiating a delegate? What is a delegate? Delegate is a type. Delegate is a type. And you can never consume a type without creating an instance here. You can never consume a type without creating an instance. Int is a type. Can we use it directly? Int I. String is a type. String S. You can never use a type directly now. Same way, delegate type also cannot be used directly. If I want to use a delegate, what should I do? Create an instance of it now. I wanted to use the first delegate. What is the name? Add delegate. Look guys, just a minute. This is your method. And now, this is the delegate what you have created. Okay. Now, second step, instantiate the delegate. Add delegate. AD is equals to new add delegate. Add delegate AD is equals to new add delegate. But I have a small doubt here. This is a method. This is a delegate. Both are declared separately. Correct? Is there a link between the two? I talked in English only, na? What I asked you, this is a method. This is a delegate. Is there any link between the two? That's it. No, na. Where you have a link, both are separately declared. There is no link between the two at all. When there is no link, how this delegate is linked with the method, that's a big doubt now. Like this. This is the link. You understood? That is the link. What you are doing? You are creating an instance and passing the method name over there. You can write this like this also. Add delegate AD is equals to add. This is also fine. You can write like this also. Okay. You want to follow the traditional style, new add delegate of and pass it. A modern style we can write like this. Add delegate AD is equals to add. Come on, help me for the second one now. Come on. Say delegate SD is equals to new. Say delegate. Say hello. Say delegate SD is equals to say hello. That's it. Say delegate SD is equals to say hello. This is called as instantiating. What is instantiating? In this process, the method is bound to the delegate. In this process, the method is bound to the delegate. Why? Method is separately defined, delegate is separately defined, and there is no connection between the two at all now. And you need a connection between the two. And to do that connection, what you are going to do? You are going to create an instance and bind the method with the delegate. And we call this process as instantiation. What is that? Instantiation is what we just call it over here. Am I clear, all of you? Yes or not? Okay, so that's what. So step 2 is also done now. Final, I'll show you all the 3 steps in C language also. Wait, C language are declared. I'll show you all the 3 there. Wait. Third one. Now call the delegate to execute the method now. Call the delegate to execute the method. How do you call? How do you call this method? Add of something, some values. Like this only you call. AD of 10, 20. AD of 30, 40. AD of 50, 60. How many times I call? Listen, if I call a method like this 3 times, what happens centrally? You know, 3 stacks are created. That's what I said to you. Every time stack is created, destroyed. If you call a method like this 3 times, how many stacks are created and destroyed? 3. But now, 1 stack. But now it executes all the 3 times only in a single stack. Under 1 stack only, the execution happens for 3 times now. Okay, come on, come here. It's a value returning, right? String S1 is equals to SD of some name. String ST is equals to SD of something. And string S3 is equals to SD of some name. I'm just calling the method for 3 times now. Are you clearer? So 3 times. But now also there will be only 1 stack. But total 6 calls. Total 6 calls. But the number of stacks created are 2. 1 for add delegate, 1 for say delegate. All delegates won't use same stack. Every delegate has its own stack. Okay? See what? Did you get my point? All delegates won't use the same stack here. Every delegate will have its own stack. So 2 delegates, 2 stacks. Okay? Do you want to see the 3 steps in C language also? Watch. This is declaration. This is declaration. And instantiation. While declaring only, you initialize now. Declaration, initialization separate. You learned earlier. And declaration and initialization can be done on the same line now. So what are you doing here? You're declaring and initializing on the same line. Did you get me or not? What is the 3rd step? Calling. See that? Calling. We have all 3 steps in C language also, man. But in C language, declaration and initialization is combined off. But in C sharp, declaration is separate. Instantiation is separate. We declare it separately. We instantiate it separately. That's all. Did you get my point? All 3 steps clear? Shall we try this in our code now? Okay. Before I show you this, I want to give a note. What is it? Not like a note. Where should we define a delegate? Okay. In .NET languages, we define types. Under. That's what you're doing from day one. Where you declare a type, where you define a type here? Under a namespace. So what's our project now? Oops project. What's our namespace now? Oops project. So that's a namespace under which we define all the types now. Okay. Where should we define a delegate? In .NET languages, we define types under namespace. So it is a good practice to define delegate type also under namespaces only. But it is possible to define enum and delegate types inside of a class or structure also. I remember I already said you this point on the day when I was explaining about enums. No response for anything here. Are you sleeping or what? I don't understand. Did you understand me? I already said you this week only when I explained you about enums. An enum can be defined inside a class, but finally said you don't do that. It will become lengthy tomorrow when you're accessing. How to call? Namespace dot, class dot, enum dot, value. That becomes lengthy. So don't do that. So good thing is always directly under namespace only define it. Now also you're not responding. It's really irritating me. I said to you, I'll make you stand up in the classroom until the class is completed. It's the last warning I'm giving to all. Lazily you put your faces like this. See, it is early morning not only for you, for me also. I'm talking now. See, involve in the classroom. Don't be lazily. So it irritates me a lot. Got it? So what is that? Where do you define a delegate? Generally, all types in C# should be defined under namespace. That's a good practice inside a namespace. So everything. But finally, what is the what we said discussed like, array, even though we can do that, enum and delegate types can be defined inside of a class or a structure type also. Class or structure type also. And if you do that, what we call nested type. 3 days back only reminded you this. What we call nested type. Type inside a type. What is the class? Type. Inside of it, you're declaring a delegate. That is a type. Type in a type now. That is possible. But still my suggestion for all is follow the first option only. What is that? Under namespace. Under namespace. That's a good practice. Okay. Let me run the code. Okay. I'm adding a new class here. We will define it as delegate demo.cs. But I just simplified the name del demo.cs. It's nothing but delegate demo1.cs. Clear? Okay. In this, I want to define two methods, public void add nums, int x comma, int y comma, int z. Console dot write line x plus y plus z. Simple code. Next, public static string say hello. String name. Return hello hello yeah, this is my second method. So what I'm returning, hello, your name, how are you? Is that clear? So these are the two methods what I defined. I want to call these methods for multiple times in my code. I want to call these methods for multiple times in my code. So if you want to call these methods for multiple times in the code, tell me now, what is the good process? Calling them directly or calling them through delegate? Calling them through delegate. So what should I do now? First, I should define the delegates now. Where should I define? Inside the class or inside the namespace? Namespace. So go out of the class, but inside the namespace. Here I'm writing public delegate void. I'm writing it as calculator delegate. Any name of my choice here. Calculator delegate. For these three integers should be passed now. Int A, int B, int C. Clear? Come on. Do it for the second one also. Public delegate string something. Wish delegate string name. Did you understand me? I completed my first step. What is the first step? Define a delegate. What is the second step? Instantiate. And don't forget here, instantiation is always done in the main method. Declaration should be global here. Consuming can be done from anywhere. But declaration always make it like global. Okay. Now I want to consume this delegate now. Which delegate? Okay, I'll start with the which delegate. I want to start with the which delegate. Come on. Which delegate. WD is equals to new. See, AI is showing you the logic. See, what to be implemented. So new wish delegate. And all of you observe it. All of you observe this one. IntelliSense is showing you for the wish delegate, the target method. Listen, the target method should be having a string return type and a string input parameter. That is the meaning of this now. What is it? You pass any method here, no problem. But that method's return type should be string and input parameter should be string. That is what the meaning of it. Are you clear or not? So, and the say hello in our class exactly matches to it now. Okay? Well, second step is also completed. Third step, start calling. Start calling. It's a value returning method or non-value returning method? Value returning method. The value returning method, what should I do? Declare the variables, capture it, print it. Alright, without writing multiple lines, can I write like this? Console.writeLine, WD off, and pass the names here. Passing the names now. Okay. Console.readline. Come on, let us make it as a startup class, del demo 1 run. You don't see any new output here. Output will be same only, but difference is in the performance. Earlier, 3 stacks creation destroying. Here, 1 stack only, all the things will happen. Come on, now let me do the second also. What is that? Calculator delegate. And bind to add nums. Come on, let's do it. Help me. Calculator delegate CD is equals to new calculator delegate. And see, what is it asking? The target method should be a void taking 3 integers as parameter. Taking 3 integers as parameter. What should I pass? What is the method name? Add nums. Is it clear? But error coming here. See? There is no error with the say hello, but there's an error with add nums. Tell me why. What is that? Why you're going with parameters now? We got an error when we bound it. Why you're talking to parameters? The method parameters and delegate parameters are matching. Add number is a non-static method. That's why I'm telling you, body present and mind absent. You're coming to the class and not following the class at all. You learned already earlier. What is it? Non-static members of a class cannot be directly called from static blocks. You can only refer them with the instance. Static to static, direct access. Static to non-static, direct access. Non-static to non-static, direct access. Non-static to static, access can be done only by instance. So right now, why I'm not able to bind it here? Because add nums is non-static and main is static. Non-static members cannot be directly consumed in a static block now. So what should I do? First, I should create the instance of my class. And then I should prefix it and bind it. Obj dot. Are you clear? For static, how do you call? By prefixing class name. By prefixing, same class only I directly done. But to imagine tomorrow, if you different class, you can't do it like this now. What should you write? Del demo 1 dot. How you should write? Del demo 1 dot. Here, obj dot. Here, del demo 1 dot. Okay, guys, without writing all these things, can I directly do a binding like this? Already said you. Here also. Here also, man. I can directly do the binding like this. Okay, come on, let's call the method for 3 times. Multiple times. CD of 10, 20. CD of 30, 40. And 3 parameters, no? Sorry, guys. 10, 20, 30. 40, 50, 60. 70, 80, 90. And here, I don't require to call write line or something. Why? Because they are non-value returning methods. Okay. So I want to write like sum of given 3 numbers is where? Third one. Okay, sorry. Hmm. Total 6 calls, but the number of stacks created are 2. Total it is 6 calls, but the number of stacks created are only 2. One for math calculator delegate, one for wish delegate. One for wish delegate and one for calculator delegate. Okay, remember guys, going forward, when we work with Windows, GUI programming, every method is called there only through delegate. In console application, we're directly calling out the methods, create the instance and call. But no, we don't do it like this in the GUI. In GUI, the method calling is done by delegates. Why, sir? Because that's what I was telling you. You can click on a button 10 times now. All the 10 times the method has to execute now. So compulsory, there will be a delegate for you behind the screen to process the logic. What will be there? A delegate for you behind the screen to process the logic. I hope you guys are clear. Understood me? Okay. Guys, delegates are 2 types. Delegates are 2 types. What are the 2 types are? First one is unicast delegates. Second one is multicast delegates. What is the first one? Unicast. Second one, multicast. What is unicast? Unicast means it's a one-to-one binding. It is a means one method bound with one delegate. One method bound with one delegate. What is multicast delegate? It is many to one binding. What is that? Here, multiple methods are bound with one delegate. Unicast means one method bound with one delegate. Multicast means multiple methods bound with one delegate. There are multiple methods you're binding with one delegate here. Okay, that's called as multicast. But do remember this, guys. What do you know? If you want to use multicasting of the delegates, all these methods must have the same signature. Then only you can do multicasting. Each method has different parameters and different return types. We cannot. All of them should have the same signature. Then only. Why? Because delegate signature should match with the method now. If 4 methods are having 4 signatures, how will it match with the delegate signature now? Are you clear the important rule in multicasting? What is that? All methods should have the same return type and same parameter types. Okay. Well, I'll show you. Watch. Del demo 2. Look here, I have 4 methods here with the same signature. You know them here. Add, subtract, multiply, divide. That's all. I defined 4 methods. All methods have the same signature or not? Now I can call all these 4 by using one delegate, guys. I can call all these 4 by using one delegate. Come on, let's declare the delegate first. Okay, help me. Public delegate void math delegate. I'm calling it as math delegate. Any name you can give there, I said you. Int, xy. Int and int is important, not a, b, x, y, nothing. Hope you guys are clear. Okay, so fine. What next? Methods are static or non-static. So first create the instance of your class now. Now, come on, start with the delegate. Math delegate MD is equals to obj dot add. You already remember this now? Yes or not? Now call the MD of 100 comma 25. This is what I shown you in the previous example, guys. This is what I shown you in the previous example. Now run. Read line is missing. Nothing new here. What is this? Unicast. One method bound with one delegate. Now what is multicast? Multicast means multiple methods binding with one delegate. What is it? You can bind more than one method also with the delegate. How, sir? MD string str is equals to hello. In the next line, you're writing str plus equals to world. Now the string is hello world now. Now see, in the first line, MD is equals to, but in the second line, MD plus equals to. You are adding another method to it now. See. Are you clear? MD plus equals to obj dot sub. Sorry. Multiply. Do you know what is the beauty of this? You make a single delegate call, it will execute 4 methods. Means to call the 4 methods, no need to make 4 calls now. You need to make only a delegate call. You need to make a delegate call. It's like a team. It's like a team. Say there is a team of players now. Cricket match is going on between two teams. So in this, if I invite one team for batting and one team for bowling, or when I invite a team for bowling now, all the players in the team should come into the ground now. Will you call one by one? Nah? No need, nah. You call the team. Here also, one call to the delegate will execute 4 methods to you at a time. Are you clear? But another, there is a advantage and drawback also. What is the drawback? But all methods will execute the same values. Remember that. Not different values. All 4 methods are executing here with the same values only, but not with different. Advantage is like multiple calls are not required. Tomorrow in any scenario, you want to call multiple methods with the same input values, we can use it. Suppose there is a rectangle here. For a rectangle, there is a method called as get area and a method called as get perimeter. The logic for get area, get perimeter are different. But the inputs for get area, get perimeter are same only. Yes or not? For get area also you require to pass length and breadth. For get perimeter also you should pass length and breadth. But there the logic is length into breadth. Here the logic is length 2 plus into length plus breadth. That's what we just do it. Am I correct now? 2 into length into breadth. The logic is different. But inputs are same only now. Now, if you bind the 2 methods with one delegate and call the delegate now, 2 methods will execute of here now. Understood? That is the advantage. That is the advantage with multicasting. See, watch. Every delegate call, I put a line break. I'm making a delegate call again. I'm making a new delegate call. I'm passing now 200 or otherwise 300, 75. One call, right? 4 outputs. Is it clear? Okay, one call and you got the 4 outputs here. Okay, same like this. One more time I'll do. MD of something, some 980, 15 is my new call again. Again, you got the 4 outputs. Guys, now third time, I don't want the result of multiplication. I don't want the result of multiplication. What is that? Yes, I don't want the result of multiplication. Don't worry. MD minus equals to obj dot mul. Did you understand or not? You can add it, you can exclude it also. See now? You did not get 4 results now. How many you got? 1 result. 3 results. 1 is excluded. Anytime you can add, anytime you can exclude. How is it? Plus equal, minus equal. You know plus equal, minus equal. I don't require to give any explanation for that. Is it clear or not? Understood me? Okay, this is how you use multicast delegates. This is how you use multicast delegates. So 2 types, unicast, multicast. Unicast means 1-to-1 binding. Multicast means many-to-1 binding. Multiple methods with 1 delegate. It's many-to-1 binding. And there is a rule here. What is the rule here? First rule is 2 rules. First rule. The parameter types of all the methods should be same. The parameter types of all the methods should be same and that should match with delegate now. Second rule is the return type of all the methods should be void only. Sir, if I take int for all, not accepted. Void only. Should be void. If it is something like int or something, not going to be accepted. Compulsory, it should be void. Why, sir? What is the problem? If I have all 4, I'll take integer. All 4 are integer only now, but it won't execute. No, it won't. Why? Reason is, listen. Actually, in this example, a value returning method we directly called off like this. But what is the exact process of calling, man? This is the exact process of calling, na? You need to declare a variable and capture it. Okay? Imagine these 4 methods are value returning. Imagine these 4 methods are value returning now. How you should call? You need to first declare a variable int result is equals to, and this is how you should call. Am I correct? Tell me. But the delegate is executing how many methods? 4 methods. First method executes, result will come now. Second method executes, overrides the result. Third method will execute, overrides the result. Fourth method will execute, override the result. Finally, what will be there? The last result only. Remaining 3 won't be there now. Understood or not? That is why what they said is, you can use it only for non-value returning methods. Don't forget, these are the 2 important rules. Rule number 1. All these methods must be non-value returning. Rule number 2. The parameter types of all the methods should match. You can't change that. Void here, any parameters you take there, no problem, but everything should have the same parameter types. That's what I'm telling you. Return type should be void only. Even though return type same also not accepted, that will expand you. All are ints now. All are ints. How do you capture? MD of 100, 25. How can you hold 4 values and result? Show me. Tell me now. What will happen? First method will execute and give a value. Second method will come and override the value. Third method will come and override the value. Fourth method will come and override the value. Finally, what you have? The 4th result. Now 1, 2, 3 results are not there now. That is a problem. Okay? So it will override the things behind the screen. So that's why it's not a good practice to use it. First thing is, compiler won't allow you first. Not like a good practice. If you try to write also, compiler will give you error. Not allowed. All the methods should be non-value returning only. Parameters is your choice, but return type is compiler choice. Understood me or not? Parameters is your choice, but return type is compiler choice. Understood? Okay, so this is what we call as multicast delegate. Clearer or not? One method has, we can. Finally, binding we can do anyway. No problem with that. Okay. Well, guys, so this is how you are going to do a multicasting of the delegates. This is how you can do a multicasting of your particular delegates. Unicast delegates, multicast delegates. Till now, how many delegates you declared in the code? Till now. 3. What are the 3? Which delegate? Calculator delegate, math delegate. All the 3 are public. Okay. Watch, observe this. I want to write a new class, guys. The class name is del demo 3. And in this class, I want to write a method, private static string greetings. The method name is greetings. String name. Okay, return hello. Very good morning. It's a simple method, guys. I want to call this method for multiple times in my code. I want to call these methods for multiple times in the code now. Then declare delegate now. Declare a. Do you want me to declare a new delegate, or can I use any of the existing 3 delegates what I already declared? Come on. Do I need a new delegate, or can I use any of the existing 3 delegates? We can use which delegate, na? Why? Which delegate is matching? See? String return type, string parameter. Which delegate is matching or not? Array, reusability. Yeah, all types have reusability, na? So what I'm trying to tell you now, before you declare a delegate, make sure there is no other delegate with the same signature already declared. Don't have duplications first. You declare one more delegate here and both are taking string only, both are returning string only, waste na? Reusability. Make sure of the reusability. But sir, these 3 delegates are declared a month back. Today I am declaring this one. I don't remember what I have already a month back now. This can be a problem. The first 3 delegates are declared today, and you are defining this class a month later. Suppose this is August 30th, it's August 31st. September 30, you are writing this class now. Which class? At that time, we don't remember now what delegates are defined already. So what you require to do, you require to open each and every class and verify whether any delegate matches or not. Understood me? So first you will go to del demo 2, check it out. Oh, it's not matching. Then you'll come to del demo 1. Yeah, it's matching. I can use it. Are you clear? But imagine if you have 30, 40 classes like this. Opening each file and verification is a time taking or not? I'm not saying it is not possible. What I'm saying is time taking. Every time, open every file, verify, that is time taking. So make a habit of declaring all delegates in one file. Make a habit of declaring all delegates in one file. Don't write some delegates here, some delegates here. That's a bad habit. All delegates under one file. So tomorrow it will be a single point where you can verify whether you can use an existing or define a new now. Did you understand me? So what the good practice, add a code file in the project. Let us name it as delegates.cs. All delegates, this is a central location now. I'm going to put now. First, namespace, oops project. Go to your first file. Bring the 2 delegates here. Go to your second file. Bring the delegate here. Now see, all delegates in one place now. Are you clear? So not after 1 month here, after 1 year, you want to define a new delegate. You don't require to scan multiple files now. What to do? Come here, check it out. Present, use it. Not present, define. That's it. Okay. See guys, when I given the code to you, I given it like this only. First, what I done, add a code file named delegate.cs and defined all the 3 delegates here. Clearer or not? Second, my first example, del demo 1. And here I use the 2 delegates. What is it? Calculator delegate, viz delegate. And next, multicasting, what I explained you. And here I used math delegate. So going forward, am I not going to declare 2 delegates means? Why not? I will declare new delegates here based on the requirement. But I don't declare new delegates if the existing matches now. Now tell me, for this, do you want me to declare a new delegate? Tell me. No. But see, do you want me to declare a new delegate? Yes. Why? This is a double return type. The existing is string return type. They're not matching. Yes is the answer here now. Is it clear? That's what. Be cautious in writing the code. Be cautious in writing the code. Avoid duplicates first. That will make you a lot of confusions going forward, because see, right now only we have so many classes here, and all these things will be confusing. But imagine here in the real time, in a solution, there will be 10 to 20 projects. In every project, there will be hundreds of classes, and managing all this is going to be a nightmare to you. Clearer or not? I said to you when I was talking about these multiple projects in my company, we have a solution with 42 projects, not 5 or 6 projects. How many? 42 projects. We need to manage all. Every project has lots of classes in it. Okay, if you don't follow these naming conventions properly, if you don't follow all the standards what I'm telling you properly, it will become a nightmare to you to remember the names and follow all the appropriate things. Be careful. Is it clear, everyone? Understood about the delegates? We are not done about the delegates. We have still a few things to talk. We'll discuss on Monday. Let us stop here. We'll meet on Monday. If you want to add delegate, but with that signature, the delegate is already present. With that signature, delegate is present. Use that now. Why you want to define again now? What we have to do then? Use that one only. Use the old one. What will names do to you guys? You can have any name now. Don't bother about the name. ప్రాపర్టీ సెట్ చేయమంటుంది అంతే కదా.